Hello, students. Welcome back to the new video lecture. In this video, we'll talk about more about the list. So in our last video, we have discussed what actually is a list. List is collection of the element, and we have used arrays to manage the data, to store the data in as a list. So the problem with the array is, the first problem with the array is it is of fixed size. That means it is a static list. Now, what I want to do is I want to have a dynamic list. Dynamic list, right? What do I mean by the dynamic list? The dynamic list is a list which never gives the array index out of bounds. What does that mean? Is even if the list is full, I still will be able to add the values into that. So how can I do so? I already know one of the lists in Java, which is the ArrayList. So we can use the ArrayList to add the elements, which will never give you the array index out of bounds. But since we are learning data structure here in this class, in this course, we discuss both the mathematical view, the abstract view, as well as the implementation of the data structures. So now we are going to design our own dynamic list, which is actually the ArrayList class in Java, right? So we already have ArrayList in Java. Now we are going to design our own ArrayList. So remember one thing, the ArrayList is not a data structure, right? It is not a data structure. What does it is then? So it is basically a class. It is a class, right? That uses array as underlying data structure. What does that mean is whenever you are going to create the object of the ArrayList class, at the backend, it creates an array. It stores and manipulates the data into the array. And now, what is the difference in the ArrayList and the array then? So remember, array is a data structure, the way of storing the data. ArrayList is a class. So that means we are going to have an abstraction, a layer of abstraction, where we were getting array index out of bounds. We cannot grow the size of the array. We cannot shrink the size of the array. So now we will be having some methods here in this class that will automatically grow the size of the array, shrink the size of the array. And in addition to that, we'll be having more methods that we can use to manage, to manipulate, to organize the data into arrays. What are those methods that we want to have in the ArrayList class? We already know, I mean, we have discussed this in our programming classes. But right now, what features that I want to have in this list? So I'm saying my list will be considered as an empty list if the size is zero, right? What does this mean? Size means we will be using one variable, which is the size. Size is different than the index number. For example, if you create an array of size 10, the indices start from 0 to 9, but the size will indicate how many elements are stored in that list, which is mean by the size. So if there is no element in the list, the size is 0, right? And the list will be considered as an empty. For example, the size of you have created a list array for 20 elements, but you have just stored 7 elements, so the size would be 7. So this size variable, instance variable, we will be using to just maintain that how many elements are available in this list. And then I will be able to add any element into the list, right? So we have the add method in the ArrayList class. Here we will design our own add method. So what does this mean? I can add either at the end of the list, or at any given index, right? So I will be able to add the elements at any given index number or at any or at the end of the list if the index number is not given. Similarly, I will be able to remove the elements, right? Remove the elements either from the end of the list if the index is not given, or at any given index number, right? At any given index. So I will be able to remove those elements. What else I want to do? I may be able to set value, right? Set the value at any given index number, right? So set the value at any index number. At any given index, I may be able to set the value. When I say the set value, meaning modify, right? Modify, store, or whatsoever you want to say. In addition to that, I must be able to get or access value at any given index. right? At any index, from any index number, I can get the value, right? Okay, what else I can have? I should be able to count the number of elements in the list, which actually is the size. So I will write a method count, which will give me the size of the list, right? You are getting the point now. What else I can have? At any given time, I may be able to clear the list. What do I mean by the clear? Whenever I call the clear method, it will reset the list to default, right? Reset the list to default means the size will become 0, all the elements are removed from the list, and the size of the list will become the original size of the list. Now, this is an important question. When you create an object of the array list in Java, let's say, what do I mean by this is, let's say, for example, in Java, if you write something like this one, let me just put it over here somewhere like this one. I will remove this later on. Say, suppose you are going to say, hey, array list, for example, list is equal to new of array list, right? When you create this by calling its constructor, right? Okay. By calling its constructor, what happens? An array for the 10 positions are created. I mean, by default, the array is created for 10 positions from 0, 1, 2, up to 9. So default size of the list in Java is 10 in array list. So we will be using the same idea here. We will be creating a list for default size, which is 10. And whenever I'm going to call the clear method, it will clear it. All the elements are removed. No matter if the size of the list is 1000 elements, it will again make it to the default, which is of size 10. So it will shrink the size. One thing. The second thing is, what should I do when I'm going to increase? For example, when you created the object of the ArrayList class by the name list, right? So it contains the array of the 10 positions. Now you want to add 11th element. What will happen? It will actually grow the array, not grow the array. It will create a new array, right? For example, list is now pointing to this one. Now later on, this will point to this one. All the elements from this list will be copied here. All the elements from the list is copied here, and then the new slots are also available. How many new slots are available? So by default, Java doubles the size of the list, right? Double the size. For example, if it is of size 10, the next list would be of size 20. Then the next list would be of size 40. Then the next list would be of size 80. When I say list, it is actually the array, right? So whatever is the size, we shall see how we can do it in Java. I mean, and how we can write this program by our own, but this is how we are going to manage it. So let me just remove this hole so that we can get back to our original work, right? So now, okay, we will be able to clear the list, and what else we will be able to write one more method, which is contains, which will tell me which will help me to find out an element from the list, right? For example, list of a student, does Ahmed belong to the list of students or not? So this will return me either a true or a false value, which is a Boolean value. And finally, we'll be able to write a toString method. We'll write a toString method, which will print out the elements of the list as the Java array list is doing that. Right, this is the list of the methods that we will be writing in our program. So with this, let me just move it somewhere here, and now we'll get back to our Java, and then we'll be writing this code so that we can understand how to make our own ArrayList class in Java. So what I have done here is I'm going to create say a new package. So at in any folder, so you can create a package. Let's say the array list, right? In this package, I'm going to create a class. So remember, you already have a array list class in Java, right? So that means if you already have a name of the class, can you use the same name? Yes, you can, because that ArrayList is available in java.util package, which is a different package. You are creating your own package. In this package, you can have the same name with that is no problem. So I'm going to use the same name, ArrayList, right? ArrayList, and I'm going to create it like this one. Okay, so what I'm going to do here now is first of all, I have to decide what would be the instance variables that my class will contain. So as I mentioned, this first thing that it will contain is the size. So I'm going to say, hey, private integer size, right? Then what else it contains? The second, what else it contains? It contains the list of items, list of values, list of data elements, right? So a list of elements. So in order to do so, I have to create an array. Now, one point, what is the data type of the array that I am going to create? Well, that I have missed here. This list is a dynamic list, as well as it will allow me to store any type of data, right? Any type of data of my choice. For example, if I want to store strings, I will be able to store strings, integers, doubles, whatever I want to do. That means I want to create a generic list. So in order to do so, I will be using generic data type. How to use the generic data type? We have learned that in our programming classes, but if not, you just need to do, let me just give you the idea what you need to do while you are creating a class, right? After the class name, in the angular bracket, you will define your own data type, whatever the type of the data you want to store. Say, suppose I want to store any type of data, right? You can give any user defined name, or you can, let me use this any type of the data, right? So any type is my user defined data type that I'm going to create here. Then the second thing that I need here is the array of items, array of elements, array of data of any type. So private any type, that is my type, right? That we have just defined, user defined data type. It could be A, B, C, D, P, Q, R. Usually it is P or capital T or capital E, but you can use any name, right? Any type of array. Oops. Any type of array, right? I want to create an array of any type. Now, what would be the size of this array? That we will define in the constructor. But in order to do so, one more thing that we need here. So, okay, name of this array. So say, suppose, let me call items. This will contain the items. The name of the array is item. And the type, the name of the array is items. The data type of the array is any type, which is my user defined type, and it can hold any type of the data. One more thing that I need to do here is the initial capacity of the list, the fixed size, the default size. For that, I'm going to define a public static final capacity variable, right? Which is default value is 10 that we will be using here, right? Okay, the data type, of course, is integer, right? Public static final integer capacity, which is initial value is the 10 value. Now let's define the constructor for this class. If I define the constructor for this class, let's say would be array public array list, right? What I want to do here is, the first thing that I want to do is I want to set size to 0, default value, because whenever you call the constructor, you are going to create a new list, right? So at that time, size will become 0. And now what I want to do is I want to create an array of the default size. So the array for the default size means I'm now going to say items is equal to new of the array of what type? Of any type. But now any type is not a type in Java. That's my user defined type. So what I will do, I will create an array of object, right? Object, and what would be the size of the array would be capacity, right? Capacity. And now there is a problem here. The object array will be, this will create an array of the objects, and I want to store the array of the objects in items whose data type is any type. So that means I have to now typecast it to any type, right? And of course it is array, so array of any type. That would be all fine now. So what it will do, it will create an array of objects of the default capacity, which is 10, and will typecast it to my user defined data type, which is any type, and will store it. The address will be stored to the items. So items is just the name of the variable of that array, which contain the address of the 0th index of this object array, right? Okay, that's what I'm done with the constructor. Now let me write the simplest method first, which is the clear method. So public void clear the list. And what does the clear method does? I already explained it reset it to the default. So if I try to reset it to the default, what I need to do? I'm going to simply do the size is equal to 0. And then what I'm going to do, I will reset the list of the, I will be resetting this to the default size, right? So what I'm going to do is, so if this contain anything, I have to do same thing. Items is equal to, let's say I'm going to say items is equal to new, okay, typecast to any type, because I just need to create a new list and assign it to the items, and new of objects of the original capacity, right? So original capacity, that's it. So if you think, okay, of course it is object, not the objects. If you see, these two are actually the same things, right? So in the constructor, so instead of replicating my code, I can simply call this clear method in the array, my constructor. So that will save my line of codes, and of course it is the better way to organize this one. All right, now later on, at any given time, I should be able to know the size of the list. For that, I can write a method public. Of course, it is going to return integer size, get size or size, whatever you want to call it. Size, return whatever is the size of the list, right? Simple size method. Now, let's write a method. Okay, let me just write simplest methods first. As I mentioned, public boolean is empty, right? That I already explained. It will tell me that whether my list is empty or not. So how can I check that? I can check if the size is 0, the list is empty. If the size is not 0, the list is not empty. So I can simply say either I can use if size equal to 0, then return true, otherwise return false, or simply I'm going to say return whatever is the answer of size. Since I have the method now, I can use this method is equal to 0. So if it is true, it will return true. If the size is 0, it will return true. If size is not 0, it will return false. So it will tell me whether my list is empty or not. Okay, now let's move next and try to write method to add an element. So for adding the element into the list, we have to do two things. One, we have, if the index number is not given, we will add the element at the end of the list. If the index number is given, then we will make a space for that element and we'll add the element there. So let's see how we can do so. So what I'm going to do now is, let me write public void add method, right? So it will add the element without any index number. That means at the end of the list. So that means it will receive the data element of any type, right? Because any type of data, for example, data, right? Any type of data or value, whatever you want to say, that we want to store. Okay, now what I want to do is, first of all, I have to make sure the array list, the array has the capacity to accommodate the new element. If it has the capacity, I will add it. If it doesn't have the capacity, then I have to increase the capacity of the list, and then I will add the element to that list. So let's see how we can do so. So what I'm going to do is, I'm going to do simply if I have to check whether the element, the size of the list is full or not. How can I check that? The array is already full or not. I can check that. Let's say, for example, items.length, right? If it is equal to what? To the size. If the size and the length of the array items they are same, that means list is already full. So if the list is full, what I have to do? I have to increase the size of the list, isn't it? So what should I do then? In order to do so, in order to increase the size, we have already seen in our previous video, I will create a temporary array, copy all the elements to the new array, and then I will be just making changes, the referencing to the new array. So for that, what do I mean is, I'm going to create any type of temporary array, new of course, I need to typecast it, any type to new of object array of what size. So as I mentioned, it will increase the size by double. So whatever is the original size of the array times 2, right? So if it is the size 10, it will make it 20. The size was 20. Next time you want to add 21st element, the next size would be 40. So the new array object array will be created. Temp with the name temp will be created for the 40 locations, or if it is first time will be for the 20 locations. And now after doing so, what I need to do, I need to copy everything from items to the temp. For that, I can run a loop for integer. For example, I starts with 0, I is less than the items array dot length, right? I plus plus. What I'm supposed to do in this loop is copy everything. So what I'm going to do is I'm saying temp of I, that we have seen in our previous lecture as well, items of ith index, that we just need to copy, right? Once it is copied, everything is done. After this for loop, what I am going to do now is I am going to simply say that temp of, okay, items, whatever the address of the temp is, store it to the items, right? So now the new array with the same name is now available. That is what is happening. Once this loop is over, and if this condition is true, this loop is over. After coming out from this loop, that means now is the time I definitely have the capacity available to accommodate the new element. So in order to do so, now what I will do this simple thing now, which is the items at the size index, right, is equal to whatever the value you have received as the argument here. So store this data to the size, or you can use either an index variable, or you can use the accessor method, which is the getter method that we have just defined, which tells the size. And now once we have stored it, what I need to do, I have to increment the size, so that next time size will be pointing to the next index number. That is one case that when we have the values available, I mean the index number is not given and we are going to store it here. One thing that you need to notice here, this is something that we are going to do again and again. So why I'm saying so, if you see here, we are in the clear method, we are also doing the same thing. I mean, we are going to create the array of with the 0 size, but it may happen that you already have some elements that you want to store. What do I mean here is, in my clear method, I can actually do some changes here. Instead of directly creating items here, I can actually copy this, okay, or we can actually understand it better with one more example later on. Let's move next, and we can actually then come back to this point. So this add method will add the elements at the end of the list. Now, for example, now I want to give another definition of the add, which accepts two things. One, integer index. At a particular index number, I want to now store the value. So for example, I'm going to say I want to store any type of data, right? Any type of data at the given index number, right? So how should I do now? So if the index number is not given, I can do that. If the index number is given, I have to do so. So what should I do now? I have to now once again make sure, do I have enough space to accommodate the new element, data element into the list or not? If it is available, all fine, I can just add it to the index number. If it is not available, then what I have to do? I have to once again create the new list. I mean, I have to actually repeat this whole code here so that I can create a new list. I can copy all the elements and do so and so on. So in order to avoid repetition of this code, I can actually write a method here, which is public void, say ensure capacity, which actually ensures the capacity, right, which receives integer capacity, right? And whatever the capacity we are giving it here, it will make sure that capacity is increased here, right? So what I'm going to do in this code is the simple thing, right? For example, already the size of the list is, say, suppose 25, and you are giving to increase the capacity to 10, which doesn't make sense. This capacity that you are providing to increase, you may say it is ensure capacity or increase capacity method. So you are giving the value which is already smaller than this size. So I do not need to do anything. But if the size, the capacity is greater than the original size of the existing size of the list, then I will increase the size of the list in this method. So in order to do so, first of all, I'm going to make a check if the capacity that I am receiving as an argument is it smaller than, right? Is this smaller than this size? Right? If this is smaller than the size, I do not need to do anything. I'm simply going to return, and I say I'm unable to do so. Otherwise, in an else part, or you do not need to mention else because return will return, and you do not need. You will reach to this line number 27 only if this condition is false. And then what you are going to do now is you can create an array, right? Temporary array, right? Temporary array, right? And you can typecast it to any type, for example, new of object array of whatever is the capacity given. So capacity, whatever is the capacity is given, we can actually do it with this one, right? We have created that array for this capacity. And now at the same time, what I can do is I can simply now say, copy the elements from the existing array to this temp array. For that, I'm going to run the loop that we already have. So integer I, which starts with 0, I is less than items dot length I plus plus, right? I plus plus. Or instead of having this items dot length, I actually have to use this size variable. That whatever is the size of the list, I have to copy the element until that size. And then what I'm going to do here is temp of I is equal to the items of I. Once we are done, then what I have to do, I have to switch the addresses, and I'm saying, hey, items is equal to temp. So the advantage of having this method now is I do not need to repeat this code again and again, and I will be calling this method only. So what does this mean is here, instead of having this, I can simply call this method ensure capacity. Right? And what would be the capacity that I want to have? Whatever is the size of the existing size of the list times 2, right? I just want to make it double. So this will actually does the same thing, but this will be called by this method. All right. And actually, I can do the same thing here in the clear method as well. While I'm creating this one, I can also call this ensure capacity method here. Capacity method by giving the original capacity. Right? It will actually reduce the line of codes and will make my code clear and nice and clean. You can just pause the video and see how this will impact. Okay, now let's move next. I actually do not use the brackets now as well because I just want to make less number of lines. Now, coming back to my add method, add the value at a given index number. What I need to do, what am I supposed to do? Again, first of all, I will check if the size is, if the items array has enough space to accommodate the new data element, I will do so. Otherwise, I will call the ensure capacity method so that we can have the bigger size of the array and we can actually add the new element there. So I'm going to do the same thing if items.length, is equal to size. In that case, that means the list is already full. First of all, increase the size of the list. So call the ensure capacity method, right? And what would be the new capacity? Whatever is the size times 2, right? So once you are at the line number 43, the list is already increased. The list is already having the capacity. And now at this point, what I am going to do is I have to make a space for the, let's say, what do I mean by this? Let me explain this with one example. Say when I'm going to create a new array, let's say I am going to have this array list. Say this is the array list. Okay, so for example, this is the current position of the array, and I am calling this method. For example, I want to add the index number, say 3, and the value that I want to add is 27. Right? If I call this method, we already know what ArrayList does. ArrayList will add the 27 to the index number 3. But how it is being implemented right now, we are writing our own code. So I need to actually write my code at this line. Let me just point. I need to have my code at this line number, right? At this index number. So index number 3. So, but index number 3 already contains some value. What should I do with this one? If I simply say the items of, like, for example, if I simply say items at the index number 3 is equal to 27, so this will overwrite 8, and I will lose this value, right? Which I don't want. So what I will do now, in order to insert the value at this index number, I have to make a space for this new element. In order to do so, what I will do, I will shift the last element, whatever is at the last element, I know it is the size variable. I will move it to the next element, right? Next available position. And then I will move 11 here, right? 24 will move here. 11 will come at this point. Then I will move 2 here at this index number. I will shift every element to the next index, right? So I will get a 9 here. Then I will move 8 here. And then only I will be now able to have this space empty, and then I can store 27 here, right? This is what we are going to do. So what we will do, we will move every element to the next index number, and then we will store the element at the given index number. In order to do so, what should I do? What would be my strategy to write this code? So let's see. What I'm going to do now is, so after ensuring the capacity of that available capacity is there, what I have to do is I will now simply run a loop to shift all the elements from the given index number to one step forward. So I'm going to run this loop for integer, for example, I, which is going to start from the last index. Remember, I have to move the last element to the next index. Then I will keep on coming back up to the index number that where I want to store the value. So I'm going to say, hey, start with size, whatever is the size, right? And until this I is greater than whatever the index number user want to store. And now remember this one, the index, and then it is the decremental operator I minus. And in this loop, what I'm supposed to do is I will move the element to the next index. So I'm going to say, hey, items of I, right? I is going to start from the size, which is index, the last index plus 1, right? Is equal to items of I minus 1, right? So the previous element, if for example, in this case, the size of the list is 7, right? So what I'm going to do, the size of the list is 8. Starting from 0 to 7 are the index numbers, but the size of the list is 8. So what I'm going to do, I'm going to start from the index number 8. My loop is going to start from the index number 8. And what I'm saying, and whatever is at the 7th index, 8 minus 1, copy to the 8th index, and do that until you reach to the index number that where we want to store the value. Once this loop is over, this slot will be available, right? This slot will be now empty. And now only what I can do is I can now place whatever the data element we have received to this index number, right? So the index number, whatever the user has given, index number that whatever the user has given is now available, and I can store this data over here. Once I have stored here, again, I have to increment the size because the new element is added, and now I have to increase the size of the list. Pretty much simple now, right? So that is how this add at any given index number will be used. So if you observe, I mean, of course, we are going to test this with a tester class after we have written all those methods that we have listed in the right side of this screen. So if you observe that this is actually the same thing. This add method is going to add at the index number 0. So can I do one thing instead of writing this whole code again and again, because this is going to increase the capacity and then it's going to add the value at the given index number and so on. I can actually remove this whole code, and what I can do is I can remove this whole code. Let's say remove this whole code, and instead of that, I can call this add method, and I can pass the index number, whatever is the size. At the given size, add the data that you are getting here. So it will make my code more clean and clear. So instead of having multiple calls, I can simply, use this one, right? Pause the video if you want to get clarification on that, and just take 1 minute to understand what we have done. Okay, once we have written this code to add the element, now let's see how we can remove the element from the list. So let's see. Let me just now move ahead and write a method public void remove. Whenever we are going to call the remove method, right? Remove method. Remember the remove method, if the index number is not given, will always remove at the end of the list. So in order to do so, this is very simple now. What I need to do, I simply need to decrease the size. That's it. I can decrement the size. When I decrement the size, that means my pointer is now one step back. That the last element is no more part of the list. I do not need to do anything. So this is simple implementation of the remove method. But now, for example, if I want to remove the element for a given index number, public void remove from the index number, from a given index. If you want to remove the value, say for example, you want to remove the element at the index number 4, then what should I do, right? I want to, let me just clear this so that we can, okay. So let me just clear some of the stuff from here, from on the screen. Okay, right? So let's see. Now, for example, I want to remove the element from the, let's say, the index number 3. So what should we do? So index number 3 is given here. Then what I'm supposed to do is, I mean, like we were doing, adding the values. So when I'm going to delete the element from the index number 3, I'm going to remove the element from the index number 3. What I can do, I can simply shift all the elements after this index one step back. What do I mean is I can move 9 here. 9 will override 8. I can move 2 here. So 2 will override 9. I can move 11 backward. So 11 will override 2. I can move 24 here. 24 will overwrite 11. And then I will decrease the size. Even though if 24 is there, this will not part of the list because we have decremented this size. That's how we are going to use. I mean, that's the logic that I'm going to implement here now. So let's see how we can do so. So removing the element from a given index number, what should I do is, first of all, I have to make sure the index number that user has given is a valid index number. So for example, if I ask you to remove an element from the index number -4 or the index number which is 15, which is not in the list. So what should I do? I have to first of all make sure the index that user has given is a valid index. If it is less than 0, or if the index is greater than the size, right? If the index is less than 0 or greater than the size of the list, that means that is not a valid list. I can throw the exception, index out of bound exception, new say array index, or let's simply index out of bounds exception, right? I can simply throw that. So bounds, this is spell mistake, out of index out of bounds exception. I can throw this exception. And then if this condition is false, then only we'll be able to reach to the line number 52. If the condition is true, our program will throw the exception and will terminate abnormally, right? But if I am able to reach at this index number, now that means the index is valid. If the index is valid, then what I have to do? I have to shift all the elements one step backward. So in order to do so, I simply can run a loop, integer for integer, I, which starts from the index number where you want to remove the element until the size, right? Until the size I is less than the size and I plus. And what am I supposed to do here is I simply need to move the last element to the first element. So I'm saying items of I is equal to items of I plus 1, right? For example, if you want to remove the index number 3, so copy the 4th element to the index number 3. The loop will start from index number 3, right? And then you are saying copy the elements of the index number 4 to the index number 3, and then next I will increment and it will keep on doing until the size of the list. Once you are done with this loop, that means you have copied all the element back. Now you need to simply decrease the size of the list, size minus. That's it, right? That's simple. So now what else I can do is what else I need to write the methods here is, say suppose, let's move next, and we are able to write the add methods, remove method, let's say to get an element from the list, right? So getting an element from the list public, which obviously is going to return the element. Which type of element? Of course, any type of element get. right? Getting from a particular index number, right? From a given index number. How should I get the value from the given index number is now simple. First of all, again, I have to make sure the index number is valid or not. For that, I can use the same logic. I can say, I can just copy this code, right? Just to save the time, which is to make sure the index number is valid or not. If the index number is not valid, throw the exception. If the index number is valid, then simply return the value of items at that index number. That's it. That's it, right? So we just need to simply return that value. Okay, so we are done with the get method. Now let's move next to what if I want to update the value. I want to set the value. For example, what do I mean is, say, suppose I want to change this value. Let me just first of all clean a little bit so that we can understand it in the proper way. So let's see. What I want to do is I want to now change the value at the index number 5. So at the index number 5, what I want to do is instead of 2, I want to write 22, right? At here, I want to write 22. What should I do? Again, simply, let's see how we can do that. Is simple now. I want to set the value. So I'm going to write a method public, which returns void set value, or simply the set method. At any given index number, integer index, an index number, the new value. What type of the value? Any type of the value, which is the new data element that you want to store. Again, the same thing. I will make sure the index is valid, first of all. If the index number is valid, then if the index is not valid, throw the exception. If the index number is valid, then I will be reaching to the line number 66, sorry. So, and then in that case, what I can do is I can simply say items at the index number, whatever is the index number, save the new data that you have received here. It will simply set the value there. That's it. All fine, right? Let's move next. And let's write the contains method now. Contains method is going to check whether a given element is available in the list or not. So how should I check that? So I'm going to write public boolean, right? It will tell me either true or false. Boolean contains. Contains method will receive the value and will find it from here. What type of value? Any type of value, right? Any type of value that we are looking for in the list, whether the list contains that value or not. Okay, how should I find it out? So of course, here I need to do some logic. First of all, I'm going to declare a Boolean variable, say check, which is equal to false initially. Then I can iterate through the loop. And as soon as I find the value, I will return true. If at the end of the loop, it's still false, I will say the value is not available. So I'm going to say for integer I starts with 0, I is less than the size of the list, and I plus plus. Check for the whole list. What I need to check in this check if items of I dot equals, why I'm going to use equals, because why I'm using the equals method, because it is not the integer. It is something that we are going to compare, right? In order to compare two objects, we use the equals method. Compare it with the object. If it is dot equals to this one, in that case, return true. Return true, right? So if at any position the value is found, this will return true and this method will stop. But if after coming out from the for loop, the check values is still false, I simply need to return check, the value of the check, right? Whichever it is, if it is false or not, right? I will simply return it as it is. Or you can simply say, you can either return false or you can simply return true. Say true, whatever you want to say. Or by the way, you do not need this one method. I mean, you simply need to return false here. You can do both. Both logics are valid, both are correct, right? Whichever you want to follow. Okay, now the last method is the toString method. Every class contains toString method. By the way, you can write the equals method for your ArrayList class that you should have, right? So that you can compare two ArrayLists are equal or not by comparing those values, right? But right now I'm going to skip it. Maybe in the later stage we can do that, but I'm sure you guys can do, or you can write the equals method, because in our programming classes we have already discussed it a lot. So now I'm going to write public string toString, which will return everything as a toString method. So if you remember from the ArrayList class, whenever you are going to print the list, for example, the list contains this, it is going to be whenever you are going to say, hey, print out, sys out, for example, the list num, right? List num, this is the bracket. So what it will do, it will print out something like this one, 6, 18, then 5, then 9, 2, 11, 24 in this square bracket. That's how this array list prints out the values. I want to write my toString method in the same way. So whenever it is called, it will print the values like this one. So what should I do? How should I write this? So in order to do so, first of all, I'm going to declare a string variable. Say, for example, str is equal to, and I'm going to assign this opening bracket in this one, this opening square bracket, so that the first bracket could be there. Then I can run a loop, right? Integer I starts with 0, I is less than the size of the list, and I plus plus. What am I supposed to do here is get the value from every element and store in my string, which is str. So whatever str contains is equal to str plus what the items of ith index. So after the end of this loop, my list will have the value of up till the size. But now it will, what it will do, it will also copy the 24th, right? So but I do not want to have it. Okay, in addition to that, what I want to have here is I also want to have a comma here, right? So plus the comma and a space. So in that case, what will happen is the last element will also have the comma and a space. So I want to run this loop to size -1, right? So that last element will not be appended here in this. This loop will run size -1 time. And after this loop, I can do this for str is equal to whatever the str contains plus the items of size now, the last element, right? The last element and the closing square bracket, right? That's what I'm going to do. And then after this, I'm going to simply return this str. So this will print out all the contents of the list. Very nice. That's what we are going to do. So we are able to now create all these methods that we have here. So let's test this, and then we'll come back and we shall see the time complexity of this list, right? Let's say, let me create another class here. Let's say I'm going to say ArrayList test class, right? And I need the void main here, where I will be creating the object of this array list, and we will be able to see that whether it works or not. Let me just erase this stuff from here so that we can see what is happening on the screen. So what I'm going to do is I'm going to create ArrayList, which is my array list. I'm not importing it from the java.util package. Array, for example, a list of friends is equal to new of ArrayList, right? Once I will do so, it will create the object of the ArrayList. Actually, it will call the constructor of the ArrayList class. ArrayList class constructor, which is going to call the clear method. Clear is going to set the size to 0 and call the ensure capacity method with the original capacity, which will create an array of size 10. That's what is going to happen, right? So then I can actually print out this friends directly. This will print out, this will call the toString methods. The list does not contain anything. The list would be empty, right? Will contain null, nothing is there. But if I try to add something here now, for example, list.add, friends, let me make the name to list, right? Which will be easier for me, list. So this is also list. List.add, what I want to add, for example, I want to add apple, right? Then list.add, for example, banana, right? List.add grapes, right? And now if I print out this list, it contains all these elements. Okay, this is not printing the last element, and it's going to print it as a null element. So what is wrong in the toString method? Let's see. Okay, this should be size -1 because size is the size of the list. it should be the size is always one more than the index, right? If the size is 5, the index is from 0 to 4. So we are printing from size, which is the last element, which is actually printing the null, right? Like this one. Now, for example, if I want to add, as I said, it can hold any type of the data. So if I now say list.add, can it store integer 56? Let's see. Yes, it will be able to store 56 as well. Can it store list.add 9.8? Should be 9.8. Can it store a character? List.add, for example, A should be there, right? So it's simply how we are going to add. Now, for example, if I want to remove or I want to add a value between grapes and banana, right? Banana and grapes, which is index number 2. So I want to add list.add at any given index, for example, index number 2, add, say, suppose melon, right? Melon. So the melon must be added between grapes and banana. So our array list is working very well, like the same array list like the Java library contains. Okay, so that's what we have done. Now, let's test the remove method. What if I want to remove, call the remove? So, okay, after doing this, let me, after printing this, let me call list.remove. If I'm going to remove, what is going to happen? If I remove and print out the value once again of the list, so it should be printing only up till 9.8 because we have decreased the size, so A is no more part of the list. So like that. And now if I remove, after this, let me say I want to remove index number 2. So I can say list.remove from the index number 2. So now print out the list once again. So it should remove melon. Melon is removed. Fantastic. We have done a good job, right? We have done a good job. And now let's say I want to call the contains method. Tell me my list.contains, if it contains 56 or not, right? So it should tell me true. Fantastic. What if my list contains banana or not, right? So it should tell me true. What if my list contains melon or not? It should tell me false. Fantastic. Our list is working very well, perfectly fine. All the methods that we have written. At any given time now, if I call list.clear, so it will clear the list and will be to the default capacity. And now if I print out the list once again, list must not contain anything. Okay, we are getting an error over here. Index out of bounds. So -1 is out of bounds of the length where it is. So it is going to be here. Okay, the toString method, because the list is already 0 and after that we are printing is going to cause the problem here that we need to fix. So in order to do so, if we just remove this -1, the problem will be solved, but then it contains the null. So that means we have to do something here while in the toString to the size is already 0. So what we can do is we can put a condition here. If the size is not equal to 0, then do this whole process. And if the size is 0, otherwise simply return what to return, these empty brackets. That's it, right? This will work very well now, but fine now, right? So if we are done, so that's all. The list is clear, and after that we're printing the list. The list is all clear. So if the list is not clear, it's printing the elements. If the list is clear, it is not printing the elements. Now, one more thing here. We have created a generic list. What if I want to create the list of integers only? Can I do so? Let me just remove this whole stuff. Can I just create the list of integers only? Yes, you can. I mean, you can use the angular bracket here and you can put the wrapper classes integer, right? So this list will now contain only the integers. So this is the list, that array list that we have created, similar to the Java. So now you can say list.add. You can only say 56, all fine. If I try to add now list.add A, B, C, you will be getting an error over here, right? Why? Because this cannot contain the values of type string. You have defined it as of type integer. So you are only supposed to add, excuse me, add the integer values, for example, 65. And if you print it out later on, sys out list will be all fine, right? Now, for example, if you want to create the list of the strings, so array list string, so for example, fruits is equal to new of array list, which will now create is will contain only the string values. List dot add, for example, apple, right? And now if you want to add list dot add, oops, it's not list, sorry, it's fruits dot add, right? And then you say fruits dot add banana. And then you say fruits dot add, for example, 78, which is not allowed because this list can only contain the integer values, right? This will give you the error. And if you try to print out fruits, you will get a compiler error over here because this is something which is unresolved, right? It is the argument that you cannot accept. You are giving it string, so it is not applicable. So you have to remove this, which will be all fine. So we have created our own ArrayList class. Once again, remember, ArrayList is not a data structure. ArrayList is a class that uses array as a data structure. The advantage of having the ArrayList class is that we can have now many methods which we can use very easily. My list is now dynamic list. It is no more static list, right? Now let's get back to understand some more stuff here. Whenever we are going to study about the data structure, one thing that we should be very careful is, the careful stuff is, what is the time complexity of each and every operation? So we have the operations here. So for example, what is the time complexity of adding the elements into the list, right? What is the time complexity of adding an element into the list? Let's get back into our array list, the add method, and see what is the time complexity. You already know how to compute the time complexity. So I'm going to just write it directly, but you have to evaluate it using the method that we have learned in our previous classes. So if you see, what we are going to do, we have to actually, if it is, we are going to add it at a particular index number, we are going to move all the elements one step, one index forward to create a new space so that we can add those elements. That means this add method will be, say, for example, if you are adding at the 0th index, we are always talking about the big O, or the worst case time complexity, worst case time taken by this add method. So it turns out that all the elements, if you are going to add it in the beginning of the list, all the elements of the list will be moved forward, which is, if there are n elements, all the n elements are moved to the next position, which means this is going to be the order of n. O of n time will be taken by this one, right? Next, what is the time complexity of the remove, right? Remove method. So same, in the remove method, you will be able to see we are actually running a loop to shift all the elements one step back. So if we are removing the index number 0, all the elements I have to set to back. So that means this also requires O of n time. If there are n elements in the list, it will take O of n time to move all the elements back. How about the get method? So if you observe the get method here, let's see where is our get method here. So the get method is simply going to return the index number, which is nothing but simply, if you want to access this, it is a constant amount of time, which is O of 1, right? Simple, O of 1. What does the clear method do? So the clear method is here. Let me just write it over here. The clear method is going to clear the list, right? And call the ensure capacity method. The ensure capacity method is going to copy all the elements, right? So it is equivalent to the ensure capacity method, which is again O of n, right? O of n time will be taken by this clear method to make to list clear. Contains again is going to run a loop to check whether it is all the elements are there or not. I mean, the elements is available in the list or not, O of n time. ToString, again, you have to access all the elements, n elements in the list, and you have to return it as a string value. So these are the time complexity, which are not really good. For example, if the array list is of 1 million, contains 1 million elements, now you want to add the value at the index number 100. What does that mean? You have to move all the 1 million elements to the next index number to create the space for the new element, and then you will be adding the element there. That means it is very, very difficult. I mean, it consumes a lot of time. And same is with the remove method. O of n is not really good method, not really a good time to remove an element from the list. So do we have the efficient list available in the I mean, that can take less amount of time for these methods? The answer is yes, we have that those lists as well, which is the linked list that we will be discussing in next week. Until then, take care and